Hello viewers, in today's class we are going to discuss one important and conceptual problem from limits, right? And here we have this problem that is we have to discuss this limit, that is limit x tends to 2 and 2 raised to signum of x divided by the fractional part of x, right? So here we'll discuss whether this limit exists or not, and we'll find the left hand limit of this function and the right hand limit of this function when x tends to 2, right? So here when we'll find the left hand limit, then this x approaches to 2 from the left of 2, and when we'll find the right hand limit, then this x approaches towards 2 from the right of x is equal to 2, right? And if the left hand limit exists and it is finite, and if the right hand limit also exists and finite, and both the limits are equal, then we can say that the limit exists, right? So let us first find out the left hand limit. So now here what we will do, we'll write LHL for the left hand limit, and we'll use this notation, that is x tends to 2, and here we'll put a negative sign, right? So this sign, negative sign, represents that we are approaching towards 2 from the left of 2, right? And here we have 2 raised to signum of x, and in the denominator we have fractional part of x, right? So viewers, here it is important to note that here two important functions are involved. The first one is signum function and the other one is the fractional part function, right? So what we will do here, we'll take x is equal to 2 minus h, right? And here h is a very small quantity, but it is a positive one which lies between 0 and 1, right? So now when x approaches to 2, then h obviously tends to 0, right? So we are in the neighborhood of x is equal to 2, and this point, that is 2 minus h, it lies very close to x is equal to 2, right? So here this point is 2 minus h, right? Okay, so now let us convert this limit in terms of h by taking x is equal to 2 minus h. So the left hand limit is now it reads as limit h tends to 0, and we have 2 raised to signum of x. For x we can now write 2 minus h, right? And in the denominator we have the fractional part of 2 minus h, right? So now here we'll make use of the definition of signum function and this fractional part function, right? So let us first define the signum function, and we know that signum of say y is equal to positive 1 whenever y is greater than 0, right? And signum of y always takes the value 0 whenever y is equal to 0, and signum of y takes the value minus 1 whenever y is less than 0, right? So for all positive values of y, signum of y always takes the value plus 1, and for y is equal to 0, signum of y takes the value 0, and for all negative values, that is negative real numbers, signum of y takes the value minus 1, right? And similarly the fractional part function, that is say fractional part of y, can be defined like this, that is y minus greatest integer of y, right? So this is the definition of fractional part of y. Okay, so now let us apply these two definitions to this function. Now see here h tends to 0 and we have signum of 2 minus h, right? And see this quantity, that is 2 minus h, this quantity is slightly less than 2 because h is a positive quantity. So whenever we subtract any positive quantity from 2, it is slightly less than 2, right? But 2 minus h always remains positive, right? So signum of 2 minus h takes the value plus 1, right? So this is an important concept here. See, here we have 2 minus h. Now h is a very small quantity, it is infinitesimally small, and when we subtract h from 2, then 2 minus h is slightly less than 2, but it remains positive, right? And for positive values, signum function takes the value plus 1, right? So now here we have limit and h tends to 0, so we have 2 raised to plus 1, right? And here we have the fractional part of 2 minus h, so we can now apply this definition. So here we have 2 minus h minus greatest integer of 2 minus h, right? So now let us discuss this expression, that is greatest integer of 2 minus h, right? So as we have said here that 2 minus h is slightly less than 2, right? So when 2 minus h is slightly less than 2, then obviously the value of greatest integer of 2 minus h is equal to 1, right? See, here we have 0, here we have 1, here we have 2, right? So 2 minus h, it lies very close to this 2, right? And when we take the greatest integer of 2 minus h, it is obviously equal to 1. So now we have limit h tends to 0 and 2 raised to plus 1 is 2, and here we have 2 minus h, and here we have the greatest integer of 2 minus h is 1, and now we can simplify it. So we have limit h tends to 0 and 2 over 2 minus 1 is 1, so here we have h, right? Now when h tends to 0, we have 2 over 1 minus 0, that is equal to 2 over 1, that is equal to 2, right? So the left hand limit of this function when x approaches to 2 from the left of x is equal to 2 is equal to 2, right? So now let us find out the right hand limit. So now the right hand limit, it can be written like this. So we have limit x tends to 2, and here we'll write a positive sign. Now this positive sign indicates that in this case we are approaching towards x is equal to 2 from the right of x is equal to 2, right? And we have 2 raised to signum of x, and in the denominator we have fractional part of x, right? So our line of explanation will be same as we have done in the case of left hand limit, right? So here what we will do, we'll take x is equal to 2 plus h, right? So this point, that is 2 plus h, it lies in the neighborhood of x is equal to 2, and it is very close to 2, but it lies towards the right of x is equal to 2. So this point is 2 plus h, right? Okay, so here as x tends to 2, obviously h tends to 0, right? And as we have said earlier, h is a very small quantity, that is h is infinitesimally very small, right? And it lies between 0 and 1. So now we can rewrite this limit in terms of h. So now we can write limit h tends to 0, and we have 2 raised to signum of in this case x is 2 plus h, so here we can write 2 plus h, right? and in the denominator we have fractional part of 2 plus h. Now we can write limit h tends to 0, and we have 2 raised to signum of 2 plus h, and here we have utilizing this definition of fractional part function, we have 2 plus h, and then we have minus greatest integer of 2 plus h, right? Okay, so now let us assign values to signum of 2 plus h and greatest integer of 2 plus h, right? Now see, 2 plus h is slightly greater than 2 because h is a positive quantity. So 2 plus h slightly greater than 2. So here we have 0, here we have 1, and here we have 2, and suppose here we have 3, right? So 2 plus h is very close to 2, and here we have 2 plus h. So if we take the greatest integer of 2 plus h, then it is equal to 2, right? Okay, so now here we have signum of 2 plus h. Now see, 2 plus h is always a positive quantity, right? Because 2 is positive, h is positive, and the sum 2 plus h is positive. And for positive values, we have a signum function that is equal to positive 1. So signum of 2 plus h should be equal to plus 1, right? So now this limit can be written as 2 raised to signum of 2 plus h is plus 1. So here we have plus 1, and this is 2 plus h, and here we have greatest integer of 2 plus h, and greatest integer of 2 plus h is 2. So here we have 2, right? So now we have limit h tends to 0. This is 2 raised to 1 is 2. Here 2 and 2 get cancelled, and we are left with 2 over h, right? And see, here we have limit h tends to 0, 2 over h, right? So when h tends to 0, then 1 over h obviously tends to infinity, right? So this limit is not defined, right? So it is not defined, or we can write it like this, right? So we see that the right hand limit it does not exist, right? So this is not finite, and here the left hand limit is 2 and the right hand limit is not defined, that is, it is not finite. So these two limits are not equal, right? And we can claim that the limit of this function when x approaches to 2, it does not exist, right? So viewers, this is how we can tackle these type of problems by making use of the definitions of the fundamental functions in mathematics.